So in this video, I'm going to be talking about how to make a full subtractor from a half subtractor, as well as making a 4-bit parallel subtractor using multiple full subtractors. First, we're going to be talking about the basics of a half subtractor. A complete full subtractor consists of two inputs, A and B, and the two outputs, the B out, which is also called the borrow, and the D representing the difference. The inputs go through the XOR gate, the AND gate, and the NOT gate, just like in the diagram currently showing, making a simple binary subtractor. The borrow is used to show the amount that is borrowed from the next digit. For example, 1 minus 1 and 0 minus 0 will become 0, 0, and 1 minus 0 will become 0, 1. Since A is bigger than or equal to B, they can be subtracted directly without borrowing from the next number. This makes the borrow 0. On the other hand, 0 minus 1 will be equal to 1, 1 as A is smaller, meaning it has to borrow 1 from the next number, making itself 2, then to be subtracted by 1 to get the difference, which is 1. To verify it, it can be made into a real circuit on a breadboard just like what I'm showing you right now. So this is what happens when you flip the switches like just now. As you can see, they have the exact same output. Now we can make a full subtractor. To do that, we can add a OR gate and a third input B in, then connect the wires as shown, making one additional input that can be used to perform the binary subtraction. This is very important for combining multiple full subtractors later on. For now, it's the exact same thing with half subtractors but with an extra input. So basically, we'll have the following outputs based on the previous principle stated. We can also make it into a hardware based on the simulation to get the same output. Now we can make the 4-bit parallel subtractor. We can combine 4 full subtractors by connecting the previous borrow output into the next borrow input of the full subtractor. The first borrow input will be connected to the ground to represent 0, and the third borrow output and the difference will be connected to the LEDs as shown in the simulation. Whenever there's a borrow needed, another input of 1 will be going from the previous B out into the next B in, signifying 1 is borrowed from the next digit when it's subtracted by 1. This makes a simple calculator that can subtract two sets of 4-bit binary numbers represented by AAA minus BBBB. Unfortunately, when the output binary number requires 5 figures, for example, like a fifth sign bit to represent a negative binary number, an overflow will occur, which is shown in the change in the final borrow output LED that is usually ignored. This will make the final 4-bit answer invalid, so it isn't really that functional. Anyways, here are the few output examples, which is just the basic subtractions of two sets of 4-bit binary number. Once again, we can make it into a hardware using multiple IC chips instead to get the same output. That's it for now. Thanks for watching.